My name is Fuchee Vang, and this is my topic investigation presentation for the final project in IT 414 Advanced Database Administration. Many of the topics covered in IT 414 this semester heavily involved recovery from both media and user errors in the system. Preventative database recovery methods were presented to the class, as well as a full introduction to the functionality of the Oracle database system tools. One of the areas not thoroughly covered in the course, which is of great importance to any database administrator, is security and database error checking tools. With that in mind, I'll be giving a detailed analysis of some of the features that can be utilized in diagnosing problems and errors in the database, as well as functions within Oracle that will help create a more secure system related directly with the listener process. Quick definition of an Oracle listener is that it is the first process involved in a successful client-server connection. What does it do? Basically, the listener is it actually listens for incoming client requests and then hands it over to the database server. It also establishes a line. Sorry about this. It also establishes a line of communication between both the client and the dispatcher processes. Other advanced options are discussed on the following slide. Some of the options that you can configure to the listener are specifically found in the listener.ora file. It's located by default on the Oracle home drive and can be accessed by navigating to that specific path. And specific directives to listen to ports can be defined here, such as TCP or IPC, etc., etc. And remote access to the Oracle listener is possible by establishing connection with a port identification number and authenticating to the server. Usually it's overlooked by a lot of DBAs and can be a problem to the security of the site or the actual database. More on the Oracle listener is that it contains a lot of valuable information. Over here on the left you can see two arrows pointing to specific directives that allow remote access to the actual database and the listener. Valuable information that's contained in the listener are other listeners on the system, names of those, protocol addressing, information about database services, runtime parameters of the database, and information about other critical services in the database. Now, you can see why, just by listing a few of those, that the security is a big concern to a DBA. How do we go about securing this? Basically, we're going to set a password in the file, but then although a password will help reduce malicious attempts to the system by requiring a password before any command can be ran remotely, one of the things is that it's still plain text. So users on the inside or internal employees still have access to the actual password plain text, and that in itself is a security hazard. A lot of these things can be set up with the graphical net manager application, and one of the things that should be done as well as securing it to the outside is also secure it internally. Internal security is a big deal because what you want to do is you want to encrypt the password via the listener control utility, so that once it's inserted into the listener.ora file, it's going to be encrypted. So instead of a plain text password, encryption prevents internal threats from viewing the password in plain text. So also, on another note, you can create proper read-write authorization to users and administrators within the system, so that only the people that need to see it can actually open the file and read or write to it. Alright, so as we go further into this, the security measures of the access of the security of the listener files are pretty much covered here. We're going to go into the diagnostic tools. The most important thing here in the diagnostic tool are actually simple log files. There's two types. A log file basically contains a detailed record of all errors, changes, and messages that occur in the database. Alert log files are one of them. Trace log files are the other, and trace log files can be separated into two types or branches, which are background trace files and user trace files. These files are actually used in different sequences to monitor the database in various ways. First off, the alert log files include a timestamp record of startups, shutdowns, instance recovery operations, media recovery operations, and changes to the structure of the database. It's important to go through it on a daily basis, basically to have a schedule that you can check daily if there's any errors in the database. It's a routine that a lot of DBAs should go through because it helps locate problems in which more details can be uncovered by drilling down to the trace files. Once you see an error in these alert log files, you can actually drill down deeper and find the actual cause of the problem. With that, you can go into the trace log files. Trace log files for the background trace files are created by a background process when the database encounters an error or an exception. Basically, whenever you get in the alert file, in the alert log file, you'll get the errors recorded, and once the error happens, it actually records itself to a automatic background process to the background trace file, and that in itself records every change along with the date timestamps. It's a direct implication of what happens when the error occurs. So it's a more specialized error processing log. And as we go further into this, you can actually also specify user trace files, and those are the second part of the trace log files, which are manually created by administrators. And you wonder what are user trace files used for? And basically they're created by admins to fine-tune their SQL statements, queries, and information that's actually used to query the database and get feedback back. This actually helps fine-tune those queries and helps DBAs see if there's any errors that they need to fix the code or whatnot. It also contains information pertaining to a lot of the logical reads, the number of physical reads, and statistical information occurred by the SQL statements. Basically, this can be formatted. The user trace file can be formatted with the tk-prof utility to make it so that it's easily readable to the developer. It's actually a little hard to read because of the large amounts of data and that is actually in the file once it's called and developed. So basically, that's the end of my presentation. If you have any questions or comments actually on this presentation, you can contact me via the email below, fvang@gmu.edu. And thank you for tuning into this presentation.